Hey, we're going to talk about the volumes of rotation using the shell method. So, previously we talked about the disk and washer method, whereas the disk and washer method, based off of the name there, of course, let us create like these little circular discs, almost like quarters, nickels, pennies, dimes, and stack them on top of each other. So we took these little circles that would have an area and we stack them on top of each other, so many of them that we create a volume. The washer does the same thing, it just leaves a hole in the center. So remember that when we did that, we used pi r squared because that was the area of a circle. So we made those discs and we add them up. So what we're going to look at now is a different method called the shell method, and what it does is it takes cylinders. So basically we're still doing the same idea, taking a region and rotating it around some line, but when we do and we start to add things up, we're going to treat them as little bands or shells, the outsides of cylinders. So you can think of the shell method when you start to do volume as maybe you went to the grocery store and you bought tons of cans of food. You open up all those cans, took the top and bottom off, and kind of stacked them inside of each other. So that's what we're doing here. We're taking these shells, these cylinder sides, and stacking them up so we can get a volume. So just a reminder, if you were talking about the surface area of a cylinder, it has a top and a bottom usually. Pi r squared are those two circles on top and bottom, and there's two of them. And then the band, the wall, is 2 pi rh, and that comes from basically it's a circle with a height. So the circle would be a length, that's the 2 pi r, and then the height would be the h. So when we do our calculations for integration using the shell method, we're going to think of the 2 pi rh as the band around those shells. Okay. So a little bit further here, the formula if we want to go around the y-axis, okay, or a vertical line like the y-axis is, contrary to the disk and washer method, we're going to write things in terms of x this time. Reason being, down here around this y-axis, let's see here, we need a good color, the radius will come out to some point, and we can pick that point, and we're going to let usually that radius probably be x in a lot of cases, or y depending on the axis of rotation, but depending on if it's the x or y axis, usually it'll be x or y, the opposite. But let's see here, and then the height we will be the actual function value. So the height here will be basically the f of x, and the radius will be x, but that will be only if we're going around the y-axis. If we're going around a different vertical line, it'll be something else. Okay? So the volume formula will be from the bounds a to b, wherever our region is in terms of x, of 2 pi times the radius times the height dx. So let's see that in action. So here we have a region, we want to rotate it around the y-axis, so let's make sure we throw that on the graph. Y-axis. The region we got is in the first quadrant. It goes over to x equals square root of 3, and it's under y equals square root of x squared plus 1. So we want everything in terms of x if we're going around the y-axis. So this volume will be, I'll write the 2 pi out front from a to b of the radius times the height dx. So let's see if we can figure everything out here. The bounds in terms of x are going from 0 to square root of 3. So in that case, a is 0 and the b is square root of 3. Okay, so that's how our region's running. Okay, not looking at the y values because that would be a disk method, which would be fine to use here, honestly. We're just looking at some variations. Excuse me, it would be a disk method if we're going around the x-axis. Okay, so let's see here. So now we need a radius, and I said that radius would be x, but let me show you why here. So if we draw some small cans out to some point, that radius will be x, and the height will be the function value. Now if you draw some bigger cans up to a different height and going out further, that has a different x value, but we still call it x. So the radius in these cases will be x. And the height will be the function value up here. How high it comes up to that blue line. So that blue line is the square root of x squared plus 1. So I'm going to write that as to the 1/2 power. So the integral that I get, or the integration that I'm going to do, is 2 pi and the bounds from 0 to square root of 3 times x times the square root of x squared plus 1 dx. So let me come down here. The height is that square root of x squared plus 1. So I need to integrate that. So it looks like a u substitution to me. U equals x squared plus 1. Du equals 2x dx. 1/2 du equals x dx. So in rewriting that, we would have 2 pi from somewhere to somewhere of the x dx will be replaced with 1/2 du, and the x squared plus 1 will be replaced with u, so it'll be u to the 1/2. Now I can get rid of this 2 on the outside by canceling with the 1/2 on the inside, because I can pull the 1/2 out. Now I'm going to back up and do the reverse power rule. So I'll have pi on the outside, u to the 1/2 goes to u to the 3/2, divided by 3/2, it'll be 2/3. Okay, so that's the integration I get in terms of u, but let's put it back in terms of x. So it'll be 2/3 pi of, let's see here, x squared plus 1 to the 3/2, and then that'll be from 0 to square root of 3. Okay, so let's see here. We'll let x equal square root of 3. So when we do that, we got 2/3 pi on the outside. When we plug square root of 3 in, squared, it becomes 3, plus 1 is 4. Square root of 4 is 2. 2 cubed is 8. Okay, so I have 2/3 pi times 8. Let's see here. And then we're going to let x equal 0. So what happens here? We're going to subtract off 2/3 pi. When we plug the 0 in, it looks like it'll be 1. So let's see what happens here. We got 2/3 pi times 8 minus 2/3 pi times 1. So technically we've got 16/3 minus 2/3. So that's like 14/3 pi. Okay, that's an exact answer. So 14 pi over 3 if you like. And if you want a decimal, just to see if you like your answer, I'm approximating that at 14.66. So exact answer, 14/3 pi. Approximation, 14.66.